Hi, all you cool cats and kittens. This is Mr. Ahlers going over your week 13, 420 to 424, PDN 4.22 to 4.441. This may be the first of two videos. I'm not really sure. We'll see what happens. Hopefully you don't hear all the background noise. So here's the PDN for Monday, 4.2.2, 4-51. Is there a relationship between the amount of physical activity a person gets and his or her perceived level of stress? Determine. Does a sentence or a sample make more sense for this question? You want to be sampling because you can't ask everyone. Remember, for it to be a sentence, you have to ask every single person. Should an observational study or an experiment be carried out to your question? An observational study if you give the observational study, you might have like lurking variables that might cause other things, like maybe there's family stuff as well, as opposed to just our school stuff. You don't really know. Motivation levels, like that might have a factor on exercising. As an experiment, volunteers are randomly assigned to groups subject to various amounts of physical activity, and then their stress levels are measured, averaged, and compared. I would prefer experiment because that helps eliminate bias. If an observational study is possible, explain how you would carry out this study. How would you get a representative sample of your population? I take a random sample of students from the high school, so I would number all students 1 to, I think it's like 2,000 kids, and then randomly select, I don't know, 100 students using a random number generator. That's my Apple Pencil. I'll take the Apple Pencil back, please. So I'm just trying to trade you for this Shiv. Trade. I can't write with that. I need my pencil. A random number generator. And then I'd ask them questions. Problem though is that students could lie. They could lie. Desire to please. I don't know. They just may know what we want to ask, but then they just lie about it in the survey. If a study asks for an association between the variables, discuss the effects of at least two possible lurking variables. Like motivation. Motivation could be one. And or like time management. Like if you have time management to be able to exercise, you might not be as stressed with all the situations. If an experiment would be suitable, outline an experiment or design. As an experiment, volunteers are randomly assigned to groups subjects to various amounts of physical activity, and their stress levels are measured, averaged, and compared. So for instance, I take 90 people, break them up into 4 groups or 3 groups, no exercise, 3 days, and then 5 days, and then ask about stress, and then compare. So that's the PDN for today. Going to 4.2.2, and we did this one, and we're skipping this. Consider the actual newspaper headlines. If an observational study was done, explain how it would have been done, explain why an experiment is not possible. If a study shows an association between variables has the effect of at least two possible lurking, that's the effect of two possible variables. If surveys are necessary, it's there's a potential force of bias to question potential difficulties in getting a representative sample from the population. If you believe an experiment was done, how long the possible experiments are designed. So for A, study 6 it to traditional back care, acupuncture, real or fake, gets better results for pain than usual treatments. Because they're talking about this fake, that's like the placebo. So there's probably an experiment. So they I'm going to use RI, randomly assign 2 groups, real, fake, and then they compare back pain. You volunteers, the problem is that you're probably going to get volunteers. So no random sampling, which means you can't imply to population. They probably would want to rate like from 1 to 10 or something. Marital strife, a heart wrecker. Bad marriages can increase the risk of coronary disease, researcher says. This is probably an observational study. And then they probably did a survey. And they probably asked questions. Asked about marriage and heart conditions. Some bias. So the word like bad marriages, nobody wants to have a bad marriage, so that's probably going to be bias. People might lie about that. Remember says maybe having a bad marriage or heart condition made people more likely to respond to the survey. What constitutes a bad marriage? Question that's have you ever could bias the results. Have you ever thought about divorce? Have you ever had a disagreement with your spouse? And that might cause like the marital strife. Might lead you to more bias, so like wording. Breastfeeding may cut breast cancer risk. Women with family history of breast cancer who have ever breastfed reduces the risk of getting premenopausal breast cancer by nearly 60%, according to a new study. So they can't really randomly assign women to get pregnant and then breastfeed. So this is going to be an observational study. So they're probably going to ask, did you breastfeed? And then, do you have cancer? Perhaps the kind of women who are breastfeeding their children are less likely to drink alcohol or smoke. Maybe women who breastfeed or eat healthier foods than those who do not. Surveys were used trying to get a random sample of responses from the world population of women with a family history of breast cancer can be nearly impossible. It's likely the respondents had something in common, like an employer or health plan. Maybe the type of people who take it or have had the time to breastfeed their children also have time to fill out the health survey. So the group was overrepresented in the sample. Can't be experiment because you didn't randomly select people. study. Oral drugs better than lotion to kill lice. A new study was found that in tough cases, a new oral medication kills parasites more effectively than prescription lotion. This is probably an experiment. So you probably have two groups, and you randomly assign them to lotion. Probably have three groups actually: lotion, oral, and then nothing. And then you compare number of lice. You're probably not going to get a random assignment, a random selection, because you would always have lice. You're probably going to get volunteers. So you can show cause and effect for the people who applied, but not for everyone. Here's your homework. Part 1. I'm going to go to 4 Tuesdays, PDN. Jack would like to know the answer to the following question. Is there an association between baldness and being colorblind? Does a sample or census or a sample make sense in this situation? Always a sample, because it doesn't make sense to ask everyone in the world. Doesn't make sense to ask everyone in the world. Should an observational study or an experiment be carried out to answer this question? Probably just an observational study, because you can just ask them. You can look at their head, look at head for the hair, and then ask if colorblind. You could do like a colorblind test or something like that, like for instance. Like some people might have a hard time seeing what number that is. If an observational study was suitable and asked for an association between variables, discuss the effect of possible lurking variables. If an experiment would be suitable, outline experimental design. So not suitable. Discuss possible lurking variables. Well, I think aren't men more likely to be bald than more likely to be bald, and they're actually more likely to also have colorblindness. So that could be like a lurking variable, is that their gender. Ooh, spicy. So 4.3.1. All right, visors for runners. Does anyone wear visors when they run? Phoebe, do you? She said no, everyone. The Style and Comfort headgear company makes printed visors as gift for women running in charity marathons. Marathons in different cities have different numbers of participants. S&C headgear needs a method for deciding how many visors of each size to print for each event. The company collects the data below for the women's circumference measured in 40 runway runners for the charity events. They score using this e-tool. What is the mean head circumference and the standard deviation for these women? So the mean head circumference wouldn't be that bad. You're just going to take 21.33 and divide it by, I think there's 40 people, and see what you get. 2133.3 divided by 40, 53.3. It was X bar is the mean. And the standard deviation is going to be a little bit more annoying. You actually need to type in all the data. But it looks like they have it all done for you. Typed it in. If you type it into this list, so you type into a list. And then you can go single variable statistics. So really the only way to do this is you have to hit single variable statistics, and then your standard deviation is right here. And we're going to go with the S, which is 1.12. And if you're going to do that by hand, you need to go to Desmos. And you have to hit table, and then you have to type in all the data points. And then you're going to type in functions, stats, standard deviation, right here, not the one with the P, just standard deviation, then X1, and it gives it to you. Again, mine's off because I just have to run the numbers. So you're going to make a histogram of the distribution of women and sketch it. So because we're using the E tool, we have it right here. Did it tell us that we wanted a certain bin width of 1 from 50 to 57? So if you go here, bin width is 1, histogram from 50. Change it there. And then you want scale of 1. There we go. Hat size is determined by the whole proportion of women's head circumference. For example, how many women with a head size measuring 55.8 would need a size at 55? According to your history on below, how many women in the sample would need a size at 52? So right here, if you need, I think 52 to 53, which is I think 9 people. Yeah, 9 people. So 9 from 52 to 53. What percent of women in the sample have a head size less than 54? So it's 40, 54. So that's 17 plus 9 plus 5 plus 9 plus 5, which equals over 40, which is 77.5%. Can I do some notes here? So interval, notes. So this means closed with brackets, hard brackets. So closed, endpoints included, parentheses, that's open, endpoints not included. 62. Questions about percentages like those in part D, problem 61 are easier to make if you have a table. Copying complete the table. How many hats between 54 and 55? 54, 55 looks like there's 4. 4, and the next one is 5. So this is 4, 5, and then that one is 0 between 56 and 57. So then this is 17 divided by 40, 4 divided by 40, and then 5 divided by 40. And you get 0.425, and then 0.1 and 0.125 is 0. If you add all this, you should get 1. It's 100%. The relative frequency is you take the number and you divide by the total number of people. So this is like they're all divided by 40. Relative frequency histogram makes percentage of that is easier to visualize. Use a histogram to compute the percentage of hats. Stickies. 52. Use a histogram to compute the hats. Okay. So this is 0.05, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. And this is 51, 52, 53, 54, 55, 56. Let's go by twos. So 51, 52, 53, 54, 55, 56, 57. So for 51, between 0 and 51, there's 0, so 52.12. That's 115, so half. Cooking. And this is 0.125. The next one is 2.25. And then 53 is 4.25. And then 54 to 55 is 0.1. And this one is 1.25.